Okay, so hey everyone, welcome to MS Inspire, and today we are back with another session. And we know that it's Saturday time, so it's Inspire time. So today we have Rishit with us, and also Dawood. So before I start the introduction of Rishit, I'll just give this to Dawood so Dawood can speak. Hi Dawood, how are you?
Uh, yeah, I'm doing great. I'm doing awesome, and I'm so excited to join the session today. It's been a while, and we hope everyone is going to be enjoying this session because Rashid actually has something really, really wow to showcase. So we are looking forward to that.
Yes. So before I hand over to Rishit, I'll just give a brief introduction about him. Well, he is a 10th grade student, so he's pretty small than all of us. He's pretty young than all of us, but he has a big mind. He has also been a TEDx and a TEDx speaker. He is an AI and cloud enthusiast and is also a Google certified mobile site developer. He has often represented India in international level hackathons and competitions and also won a few. He most recently represented the country and won the International Hackathon on Blockchain and IoT by IET. While free, he loves to conduct research and has written 7 research papers in the field of AI and robotics and mathematics. He also loves writing technical blogs and has written quite a bit of them in the past. While with this, he has also been awarded the Smartest Techno Kid Award in 2017. He has also given quite a few talks in other communities and colleges. He also was among the top 10 winners for Palo Alto networking challenges with GCP. Besides this, he also manages the communities of Kotlin Mumbai and Mozilla Mumbai. And today he's going to show us how to superpower our Android apps with ML. Okay, so that's the introduction for Rishit. So I'll just give my to Rishit. Hey Rishit, how are you doing?
Hi, Sundar. Thank you for the beautiful introduction. And before I start with anything, I just want to tell you that you can see the captions down over here. You can maybe see them now. So maybe it becomes easier for you to follow along with me. And thanks again, Sundar, for the beautiful introduction. Uh, before I start with the talk, just a bit about me. Uh, I'm a 10th grade student, as Sundar mentioned. I'm a TEDx and TEDx speaker, love hackathons and competitions, and participated in some international ones and won them too. And as Sundar also said, I love research. So I've written 7 research papers, and you can know more about me, about what I do, about the blogs I write at rishit.tech. So the URL is posted over here. You can know more about me over here. So, uh, before I start with the thing which we are all here about, how you can superpower your Android apps with ML. So, we'll be looking at a few things you can do to integrate ML in your Android applications and superpower your Android applications due to the limitless possibilities of ML. And we'll majorly see what's new in the latest Android 11, which is in beta as of now, and what new tools, what new plugins are there in Android 11 for you to very easily implement ML. So before I get started with this, I would like to acknowledge Syed Paul, who's a machine learning Google developer expert, Khan Levier from Google, and Hoy Lam from Google, who helped me build these slides, put all the content together, and reviewed these slides for me. So let's start with who the ideal audience would be for this talk. It would essentially be mobile developers who are looking for ways to build smarter applications, and mobile developers who are looking for ways to integrate machine learning or ML in their existing apps very easily. So if you have an app where you maybe need to do some OCR functionality or want to do some object recognition functionality, you already have an app and you want to do all of that now. So then this is the right talk you have come to. I'll be telling you all about how you can do it. And that's a bit about who the ideal audience would be for this talk. So first off, why care about machine learning in Android in the first place? So so I'll be constantly seeing the charts, and the team will be seeing the charts too. So if you have anything cool to tell me about these questions that I asked, feel free to put whatever you feel like in the charts. So I'll not talk much about this, why care about machine learning in Android. So we can get to the cool stuff very soon. But I'm sure you all know about how the number of Android devices have increased exponentially. So it has just the number of Android devices or mobile devices, for that matter of fact, has just increased exponentially in the past few years. And you also might be aware about how machine learning is revolutionizing almost every industry. Be it any industry, machine learning is kind of revolutionizing it. So it makes sense to make this power of ML available to everyone. How do you do that? How do you make the power of ML available to everyone? Through mobile devices. So it makes sense to integrate machine learning in Android. And all of us, we already use products like Google Photos or Gboard or Microsoft Translate. And it's due to ML that these are so much powerful. We are going to majorly talk today about on-device ML due to some reasons which we'll soon see. And Android 11 has a lot of cool stuff for on-device ML. So first off, what's this hype about on-device ML or ML on edge all about? The idea behind on-device ML or ML on edge, as you might say, is to use ML such that, opposed to the traditional approach, I no longer send my data to a server or some cloud-based system. So let's say I have an application which predicts if a photo is a picture of a dog or a cat. A very simple example, very standard example. So in a traditional approach, what I would do is send all this data, all these images to a cloud hosted server or a server in general. The server would then do the ML for me, would then do the ML part for me and return me the outputs. So I don't do this any longer. I don't send data out of my device itself. I instead get outputs or inferences from my machine learning model on the device itself. That is, as I said, I no longer need to send data out of my device. What this also means is I do all the processing stuff and the inference stuff in the mobile device itself. So coming back to the dogs and cats example I just talked about. So instead of sending all the images of dogs and cats by your users to a cloud hosted server, you instead do the inference part. So let's say you were deploying some application where you don't have where you have constraints on the power. You have a few constraints on the power. It just becomes infeasible to do so. But worth a mention, in some scenarios, the opposite could also be true. On-device ML could also take up more power, but due to the pre-processing part. But for most of the cases, power consumption is a thing to consider. Another important thing to consider is the time it takes for me to get the output or essentially run the model itself. For real-time applications, this is a pretty important aspect to consider. So let's say you're working on some streaming data. This is a pretty important aspect to consider, which is the inference time. So how much does it take my model? How many seconds or milliseconds does it take my model to run the inferences on one frame of the video or on one photo, and so on. So in on-device ML, we also care about the inference times, and they are reduced drastically. The inference times are essentially reduced because I no longer have to send data to a server, after which the server would do the ML part and send me the data back, which I would then display. And finally, this is expensive in terms of network availability. I should have the bandwidth or network to continuously send the data and receive inferences from the server. Again, if you're deploying in some scenarios where you don't have network availability or don't just have the bandwidth to continuously stream a video to a server and then get it back, you no longer have to do that because you're not sending data out of the device itself. So another important one to note over here: security or privacy, as you may say. So if you might have noticed, as I was talking all about this, I no longer send data to a server or a cloud-based system and get back from it. In fact, I no longer send data out of my device itself. So that automatically increases my privacy, as I am not sending data to a server itself. So now let us discuss what Android 11 has for you. And so we'll discuss all the new stuff in Android 11 for ML. And one of the most coolest updates is the machine learning model binding plugin. So I guess you can make a pretty good guess about what the model binding plugin would be from the name itself, model binding. Yeah, I feel you can make a pretty good guess about what the ML model binding plugin would be. So what the model binding plugin or the ML model binding plugin does is, you might have made a fair enough guess from model binding now, which is it allows you to very easily integrate your machine learning models in your Android apps. So before I move any further, I just wanted you to note that you need Android Studio 4.1 or above to use the model binding plugin. The ML model binding plugin makes it super easy for you to use a TensorFlow model in your app. You essentially have a lot less code to write that calls the TensorFlow Lite Android support library. You can import a TF Lite model with this, read the input-output signature of the model, which is what kind of data does it take as an input, what will it take, what will it give out as an output. We'll see how you can do all of this and use the TensorFlow Lite model with just a few lines of code. And you also don't have to convert everything to byte arrays. So you might know about byte arrays if you have earlier worked with machine learning in Android, but if you don't know about it, it's completely okay. We'll be seeing machine learning in Android even if you have not experimented with it earlier. What I also love about the model binding plugin is you can easily make use of GPUs and the NN API, or neural network API, very easily. So with the model binding plugin, using them has never been easier. So let's say if you want to use a GPU to run your model on device, using a GPU is just a dependency call away and a single line of code away. So a dependency call and a single line of code away. Isn't that cool? That what you can do with model binding plugin. And of course, this would make your development a lot more faster. With the features we just talked about, how you have easy support for integrating your models, and the features we just talked about, you would essentially do your development a lot more faster. So let's see how you can do all that we talked about. So the first step is to import a TensorFlow Lite model with metadata. So Android Studio now has this new option for importing a TensorFlow model. Just right click on the module you want to import it, and I don't know if you can see it clearly over here, but now under the other section I have a TensorFlow Lite model option. So just right click on the module you want to import your TensorFlow Lite model in. Then in the other section, you now have an option to import a TensorFlow Lite model. And now just pass in the path of your TensorFlow Lite model. It will import the model for you in a directory. In the module which you selected, the name of the directory would be ML, from where you will be able to use the model. So in the module you selected to import the model, a directory would be made for you called ML, in which you would have your model, and from where you would be using your model. As you can maybe not see it clearly, but I'll tell you what's written in these two boxes down over here. So as you can see over here, this shows that this allows you to add the GPU dependencies. So let's say if you want to use GPU on an Android device, it allows you to add the dependencies right from here itself. You can just check it. So I have my model location over here. It may not be very clear in the slides, but you might see something called as RPS model. So for as I was showing this demo, what we'll be doing is I made an open source model called the RPS model. So RPS stands for rock, papers, and scissors. So as an example and to walk you through the complete process, I made an open source model which allows you to classify between rocks, papers, and scissors. So you just keep your hand in front of it, show a rock, and the model will tell you it's a rock, scissors, and so on. So this is the model which we'll be using to walk you through the complete thing. And yeah, I'll also show you a demo of the same at the end. So that was the RPS model which I imported, and it's a TensorFlow Lite model. So now from my model metadata, which you can see over here. So if you click the TFLite, if you open the TFLite model file in Android Studio, instead of showing you something like format not recognized or something like that, it now shows you the model metadata. So so remember I told you earlier that you'd import your model with metadata with the model binding plugin. So now from my model metadata, which is essentially just a bit, as of now you can understand it as just a bit more text or the accompanying text with the model. So from the model metadata, as you can see over here, I can know a lot about the model. I can know what are the input output shapes it uses and a lot more, the license under which it is, and so on. You can see this info by opening the TensorFlow Lite model file in Android Studio. So as I said, I'm showing you how the rock paper scissors model, which I I just told you what it is all about. Looks like the metadata of that. So I can here see that. Oh, sorry. So I can here see that I'm expecting 224 by 224 images as input, and I have 3 labels, which is rock, papers, or scissors. So I can know. So I can know all of this from my model metadata. Having imported a model, let's finally start using the model itself. So for a streaming inference, which is most probably what you would want to do, live image classification, the easiest way would be use CameraX and pass each frame to a function which can perform the inference. So I'm using CameraX to get my live streaming data, pass each frame of it into a function which performs the inference. So as of now, what I'm interested in is the function which does the inference itself or runs the machine learning model itself. You'll see how easy it is to do this. A sample code for this is also seen when you import a TensorFlow Lite model, which you can use. So I would also recommend you to once go through the CameraX code, which takes the live streaming input and feeds it to the function. Some pretty basic code, nothing new over there. I'll share the repository link with you, and you can take a look at the CameraX code from the repo itself. Just take a look at it. It's pretty basic code. So we'll start by instantiating a RPS model or a rock, paper, scissors model. With the plugin, my model name is RPS model, which you can see over here. My model name is RPS model. So my model file name was rps model.tflite. So a class of the exact same name would be made for me by the model binding plugin. So since my model file name was rps model.tflite, I have a class called rps model. Once you do this, once you instantiate it, you need to convert your data into a form which we can use. So we'll convert it into a tensor image from a bitmap. If you, again, not something necessary to know, but what I do want to highlight over here is I'm now converting these into a tensor image. So if you use the TensorFlow interpreter, which was there before the model binding plugin, which was used a lot before the model binding plugin, and if you have worked with machine learning and Android earlier, you will see you maybe know about the TensorFlow interpreter. So if you have used the TensorFlow interpreter earlier, you know that you need to convert your image into a byte array. So you no longer need to do that anymore. And what now I want to do is I want to feed this into an image proxy. So now we'll pass in the data to the model. So first we will process the image itself, process the image from the model and get the outputs from it. So we essentially get an arrays of probability. So I have 3 labels, so 3 probabilities, saying if it is how much probability is it for rock, how much probability for scissor, and so on. So we essentially get an array of probabilities from this, and then I'll perform a descending sort on it. So I'm performing a descending sort over here because I want to show the label which has the highest confidence on the top. So I want to first show the user the label which has the highest confidence. So I'll perform a descending sort and then pick first end results. So let's say if I have a model which has 1000 labels. So as of now, we just have 3 labels, but let's say I have a model which has 1000 labels. So you cannot show the user all the 1000 labels. That would not be something very good to do. So I'll take out or filter out the top n results. And finally, I want to show the users these labels, the labels which are predicted by the model. So I'll add the label corresponding to each entry in the outputs. And that's pretty much all you need with the model binding plugin. So you can see integrating a TensorFlow Lite model using it was made super easy, and that's pretty much to the model binding plugin for starters. You can see how easy it was to do all of this. And let's say if you want to use GPU acceleration. So I also mentioned earlier that it's super easy to use GPU acceleration. So let's say I want to make use of GPU acceleration. You make an options. So I'll make an options where I specified to use a GPU. As you can see over here, I have set the device to a GPU and then build it. In the instantiation part, I would just pass this as an argument, and you can use the GPU then. It also makes it so a part of the, while the instantiation part of the model, a part of the context, which I was anyways going to pass in. I will now also pass in an options which tells it to use the GPU. It also makes it very easy for us to use the NN API for acceleration to do even more. And with Android 11, you have a lot of cool updates to the neural network API, including asymmetric int 8 weights and a new quality of service API. But as of now, I'll leave that for some other talk. So with these new neural network API updates, you can do even more with on-device ML. So let's talk about the other major development, a newer MLKit, which majorly focuses on give me a sec. Yeah. Oh, so before I move on, MLKit is now available even without having to use a Firebase project. So you can use MLKit even without a Firebase project. So now I no longer need a Firebase project. As I said earlier, a lot of these updates are focused on on-device ML. Due to the benefits I just mentioned earlier, the new MLKit now has better usability for on-device ML. You can do even more with MLKit and on-device ML. The MLKit image classification and object detection and tracking now also support custom models. So these two services with the MLKit, image classification and object detection and tracking, now also supports custom models. So what this means to you is you can have just a TensorFlow Lite model file along with the state-of-the-art models by MLKit. This also means if you are working on some generic use case, like a specific kind of object detection or doing some specific kind of image classification, MLKit is the best thing to use. So let's see this with an example. But before I move to that example, just a quick overview about what's new in MLKit. So now, so as of now, MLKit supports only vision and natural language models, with more of them coming soon. So as a part of the vision, we now also have two new models with two new services, I would say, with MLKit, post detection and digital ink recognition. So as of now, we'll not be looking greatly into these, but I'll be showing you what all you can do with it and how on-device ML and a bit of customization with MLKit now. So let's see this by an example. So what I do over here is, as an example to demonstrate it and walk you through the complete process, I build a model which can classify different food items. So I'll first start off by setting the model and specifying the TF Lite model file for it. So this is my TensorFlow Lite model file, which allows me to do food classification. And this is essentially an asset. So yeah, you can set the asset file path to the TF Lite model file. It will then run on top of the object detection model, which I want to use over here with MLKit. So the TensorFlow Lite model will run on top of the MLKit object detection model. So you can customize these options a bit. So you can see over here that I have the stream mode enabled, which is me telling it that I want to perform inferences in a streaming manner. And I also have a confidence threshold, which you can see over here, which is 0.8. So essentially telling it, if you have 80% or more confidence, then only you should take an inference into consideration. So you can try customizing these a bit. So let's get to the part where we actually run the model. So you might see some syntax similar to the previous example over here. The previous example with MLKit, with ML model binding plugin, which we just saw. I will process my image, and so as you can see, I'm processing my image, and and a thing to note over here is all of these listeners which you see over here, that is on failure listener or on success listener, are essentially tasks. So they need to be attached for every run, for every time you do an inference, they need to be attached over it. So that is something important to note. All of these listeners are essentially tasks, and you need to attach them every time, just like I have done over here. And that is all you need to do with the MLKit, and use a bit of customization with it by adding your own TensorFlow Lite model file. So I'll not talk. So let's talk a bit about where to get these models from. So in both cases, you saw that I needed a TensorFlow Lite model file. So where to get these models from? So you can surely build great models from scratch, but there are a couple of services for you with which you can essentially do stuff easier. If you have a use case which is a pretty important one, you can easily do stuff with it. So the first off is TensorFlow Lite Model Maker. So I've included a demo of TensorFlow Lite Model Maker, of a demo script of the TensorFlow Lite Model Maker, how to use it in the repository, which I'll soon be sharing with you all. But I'll not be showing a demo of it right over here, as we'll be seeing the Android apps in action now. So the TensorFlow Lite Model Maker was announced in 2020 by the TensorFlow team, and it's high performance. It runs on top of the state-of-art models, transfer loans from it. It's super easy to use, and guess what? You can also get high customization. So so it's essentially very easy to use TensorFlow Lite Model Maker, and I've also included an example of it. You can also find state-of-the-art models on TensorFlow Hub. So remember, we just walked through an example of a food classification app with MLKit. So the food classification TensorFlow Lite model was essentially taken from TensorFlow Hub. And TensorFlow Hub, you can find TensorFlow Hub at tfhub.dev. And it's an online repository of open source, high quality models, which are well documented too. So you can find a lot of models for your use cases. And another important part about this is you get to use models from the community. These are not just the only publishers, of course, but these are the publishers that could fit in a single slide. So you also get to use models from the community. And there are a lot more. There's AutoML, there is teachable machine, and so much more from where you can get models or easily make models. But these two were the major ones and both are mentioned. So I've included them. So let's get to the interesting part, which is demos, live demos. So here's the GitHub repo for this talk. It has everything implemented that we talked about today. It also has the source code, which I used to create the TensorFlow Lite models. So remember the rock, paper, scissors model? It also has the source code, which I used to create it. I would urge you to take a look at the TensorFlow Lite model maker, which is what I used to make these models. You can, and as I also mentioned, you can try out for yourselves with different models from TF Hub or make a model by yourself. So the team would be posting this URL in the chat box, but I'll also give you a moment to take the screenshot of this. This is the code repository for today's talk.
I'll just post the chat link. Okay. So meanwhile, while I post it, Balaji asked that this ML on device ML thing is currently like developed specifically for Android 11, or would it be able to can we get this update to the previous Android versions also?
Oh, you can use it with your previous Android versions too, but with Android 11 you have a cool thing, which is ML model binding plugin and the MLKit, which we just talked about. So of course you can use it with previous versions too.
Okay, I posted the link in the chat, so chat you can go through the repositories, and
great.
That's
Thank
the process till now.
So I guess you might have noted down this URL, or it's present in the chat too. Let me quickly switch my screen and let's get to the interesting part, which is demos. Give me a sec. Great. Share. So I guess you can see my screen now. I'll just wait a sec so it pops up. I see there's some. Okay, great. I guess my screen is now visible. So since I'll be showing one demo over here, which is the ML model binding plugin, and we'll be so as in the walkthrough I mentioned, we'll be making a rock paper scissors model. So this is this is the function which I have over here which will perform the inference. So let's start by instantiating my RPS model. So my model. So before I go on to this, I would like to show you the import model thing. So let's just open my project. Okay, it's Android, that's good. And I can just do right click. I'll go to new. I can see other over here, and I see a TensorFlow Lite model. So as of now, I've already imported the TensorFlow Lite model for you, but here's how you can import the TensorFlow Lite model for yourself. Let's minimize this again. Great. So I'm using a rock paper scissors model. So the name, and I'll parse it the context. Let's go a bit down. Here's the part where I convert it into a tensor TF image. So I'll convert it into a TF image from a bitmap, and what I'll pass in is my image proxy. So that's what I'm doing over here. Let's finally get to the inference part. So I'll process, process or pass in my TF image, which I just created above. And since it is since it's a list of probabilities, and I want to show the user the probabilities, the highest probabilities, I'll do a sort by descending and take the top few results. So again, in this case, we just have three labels. So so if you are building a model which has high number of labels, this would particularly be helpful. And here we have some code which will allow me to show all of this to the user. So I'm making so I'm just adding my label and my score, which would then allow me to show it to the user. And that's all you need to start integrating ML models with the ML model binding plugin. So let's go back, and here's the GitHub repository which I just mentioned. Here's the GitHub repository which I just mentioned. It has all of the codes which you might need. So we just understood how the rock paper scissors classifier works, and time for us to see it in action now. So I'll just try reconnecting. Give me a sec. So I felt that I could have done a demo in the emulator itself. I could have done a demo in the Android emulator, but nothing that beats live demos on a real device itself. So that's what we'll be doing now. So here's my application. I installed it to my mobile. Let's hope my keyboard makes an excellent background, and I'll put in front of it a rock. So this is my hand, and I can see it classifies with almost an 80%, approximately 80% probability, fluctuates a bit, that it is a rock. So isn't that pretty cool what we just did with very little lines of code? So you might have seen a bit of latency over here, but that is because I'm live streaming to you all, and also wirelessly sharing my mobile screen at the same time. You can I shared you the code. You can try it out on your own devices, and you'll see that there's almost no visible latency. So runs pretty smooth too. So with that, I come to the end of this session, and now I would be ready to take any questions if there are any.
Okay, that was a great session. Currently, I think we don't have any questions. That was the only question that was there. A question from my side. Okay, so so this was like on device, right? So normally, for like, I did like try to implement it. Okay, I admit that it was a GitHub code that I like stole and implemented in my project, but so that thing was actually using TensorFlow Lite, and it was like, so is it so what is the main difference? Can you just tell me again, like what is the difference between the old versions? Like I have used previously TensorFlow Lite in my Android mobile. So what is the new thing now that would come in Android 11?
Yeah, I'll again highlight it pretty quick, so maybe it will be good for other audiences. So one of the major differences which I would like to highlight is earlier what you would do essentially is use a TensorFlow Lite interpreter with Android and calls the TensorFlow Lite Android support library, and you would essentially have to write a lot more code, and ML model binding plugin makes it super easy for you to do that. So with also an advantage that you can very easily enable hardware acceleration, do your development a lot more faster,
Okay.
essentially a lot less code to write, and you also don't have to convert everything into a byte array as you did with the TensorFlow interpreter earlier.
Yes.
So that's about ML model binding plugin. Oh, sorry to interrupt, Sundar.
And I think like, okay, that actually, I think that would reduce a lot of performance overhead that we used to get previously.
Yeah,
Okay.
yeah, that's true. That's true. It also allows you to do a lot more, a lot faster
Yes.
with the ML model binding plugin.
Because I created an app which could help blind people, but well, blind people can't see like what it's front of me, no offense for them, but like our Android app was focused on like live detection. Like if a guy is coming from left, it would say like, hey, a guy is coming from left and he's in 2 or 3 steps. And during that application, when the machine learning app is running, we also had to run a navigation application in the background. So due to that, if we had used like we needed to use like a high performance, like a high end device which has 800 series processor of Snapdragon. If we for that, if we had used the 600 series, the app would just hang a lot and the machine learning algorithm would not even respond. So that was the heavy downside of our app, because we were like accompanied to compulsory use a high-end device. I think after this, I hope that the app would be more refined and it could work in a lower processor, lower speed, lower, I would say, clock speed processors.
Yeah, and there's also kind of a lot more you could do to increase your performances. So
Yes.
that's that. A couple of things you could also do to increase your performance, use acceleration and stuff like that. But I also mentioned about how you could use GPU acceleration in this talk itself. But for a bit more stuff like the neural network API, I'll leave that to some other talk as of now.
So in short, now it's running more natively than it used to be.
I'd not say that it's running
It's not.
or you are completely using the native techniques, more native techniques, but using the TensorFlow Lite Android support library was a native approach to this as well. So I would not say it's a bit more of a native approach.
Okay. Knowledge. Okay, then that's all, folks, today. Thanks, Rishit, for joining us and showing us this awesome stuff on ML. And I hope the people who had joined the stream and will join the stream in the future would love this content and must have used this anywhere in the project. Okay, so thanks, Rishit. Thanks for joining, and make sure everyone to like this if you're watching the stream and subscribe to MS Inspire. And we'll be back. Actually, a couple of sessions would come back in this weekend, so expect a lot of more awesome sessions this week. And it's confirmed that we'll always come during the Saturday sessions. Okay, so we'll meet you soon next week. So bye, everyone.
Thank you. It was my pleasure to present to you all about how you can superpower your Android apps.